Dear friends, Maths Aspirants is a collective of math students, research scholars, and faculty members across India and abroad, initiated by myself in 2017. And we used to arrange online problem solving sessions to help the students who prepare for different national competitive examinations. As a part of this series, today we have a session on partial differential equations, and we have Mr. Muhammed Rafeek KV is with us to engage this session. Muhammed Rafeek is now pursuing PhD at Central University of Karnataka, and he studied his MSc from the same institution, and he got gold medal in MSc, and he is a DST INSPIRE Fellow, and also he qualified NET examination. So I'm sure that today's session will be really useful for those who are planning to write NET examination or GATE examination. I would like to express my sincere thanks and gratitude to Mr. Muhammad Rafeek for being with us. And I welcome everyone to this program. Welcome, Muhammad Rafeek.
Yeah, good morning, one and all. We will discuss the problems related to the partial differential equation. In this section, we will go with the problems. In the problems, what are the theory or concept we need? That also we will discuss by the problems. So first I am going to give a first problem that came in a CSIR. Let us see this problem. Problem 1. The partial differential equation. I will write the question. The PDE, the partial differential equation, y dou square u by dou x square plus x into dou square u by dou y square equal to 0 is hyperbolic in, I will tell you what is mean by the hyperbolic and everything. Hyperbolic in option A, the second and fourth quadrant, the second and fourth quadrant, fourth quadrants, and option 2, first and second quadrant. Say first and second quadrant. Option 3, the second and third quadrant. Second and third quadrant. Option 4, first and third quadrant. First and third quadrant. I think you are know about the second order semi-linear PDE, when we can call it as hyperbolic, parabolic, and elliptic. Almost every paper we can see such a type of questions. Anyway, I will give you a short note on this one. When we can say this, I think you are not this question, right? Ready? This question you are noted, right?
Yes, sir.
Yeah, thank you. Yes, I will go with the little bit theory I will give you behind this question. So with that you can follow, if such a type of question came in, you can follow. Consider this is the theory, you need to solve this problem. Consider the following. We are not solving the question, just we are giving the, just I am giving the theory behind this. Second order semi-linear PDE. second order semi-linear PDE. Semi-linear PDE. Semi-linear PDE like this. L is the operator, plus G of x comma, G is a function of x comma, y comma, u comma, ux and uy equal to 0, where L is the operator like this. L is equal to R of x comma y dou square by dou x square plus S of x comma y dou square divided by dou x dou y plus T of x comma y dou square by dou y square. This is the L operator, and moreover here R square plus S square plus T square should be not equal to 0, and R comma S comma and T are continuous functions of x and y. It is clear, are continuous functions of x and y, and moreover we further assume that this function possesses continuous partial derivative with respect to x and y. Two conditions. One is R, S, T are continuous functions of x and y. Further assume that these functions possess continuous partial derivative with respect to x and y. Then the first condition. The first condition, S square minus 4RT. S square minus 4RT. Otherwise, you may see with B square minus 4AC. Some textbooks they are following B square minus 4AC. So S square minus 4RT greater than 0, we can call it as a hyperbolic type. Hyperbolic type. This is an hyperbolic type. If it is the case, then it is an hyperbolic type. You can check the example with wave equation. I think you know wave equation. Dou square u by dou x square equal to, this is one of the example for that, 1 by c square, dou square u by dou t square, dou square u by dou t square. This is always an hyperbolic type. So S square minus 4RT greater than 0. This is the case, then it is called as a hyperbolic type, and this is the example for that. Dou square u by dou x square is equal to 1 by c square, dou square u by dou t square. It means wave equation. Now come to the second case. S square minus 4RT equal to 0. S square minus 4RT equal to 0. That is called as a parabolic type. It's a parabolic type. Parabolic type. So you need to know this equation. S square minus 4RT equal to 0. Parabolic type. And example for that, heat equation. Heat equation is an example for that. Heat equation is a parabolic type. And the heat equation is dou square u by dou x square equal to 1 by k dou u by dou t. You can check it. It is following a square minus 4RT. Dou u by dou t equal to 0. And the third case is the elliptic type. S square minus 4RT less than 0. Whenever this, then we can call it as an elliptic type. It's an elliptic type. Elliptic type. And that is a Laplace equation. Example is the Laplace equation. Example, just one of the example, that's it. Laplace equation. And Laplace equation is del square u equal to 0. Del square u is equal to 0. Anyway, now come to our problem. I think this theory is clear, right? Hello, this theory is clear, right?
Sir.
Yes,
Okay.
sir.
Thank you, thank you, thank you. Yeah, now we will go to the our problem. So parabolic type is there, hyperbolic type is there, and elliptic type is there. And for a theory, you can see the T. Amarnath textbook. Okay, T. Amarnath from Hyderabad Central University. And let us see that T. Amarnath. More clearly, he gone through this. Okay, our equation is our problem y dou square u by dou x square plus x into dou square u by dou y square equal to 0. This is the equation. Anyway, here r equal to y, s is equal to 0 because dou x dou y term is not there. T equal to x. You can check the s square minus 4rt. S square minus 4rt. S square minus 4rt 0 square 0 minus 4yx or 4xy. You can have minus 4xy or yx. See, we need a hyperbolic. They are telling this is an hyperbolic. It's a greater than 0. We need to have the hyperbolic means it should be greater than 0 for hyperbolic. When it is possible? Hyperbolic. Yeah, tell me when it is possible. Of course, it is minus 4 is always negative and xy should be minus 4 is always positive. So should be have minus xy greater than 0, of course. Minus xy is greater than 0. For that, either we have two choices, either x greater than 0, that is possible. X greater than 0 implies y should be less than 0. Then minus xy is greater than 0. X greater than 0, comma y less than 0. Or x less than 0, then y should be greater than 0. Then minus xy is greater than 0. That means x greater than 0, y is less than 0. X greater than 0, y is less than 0. That means in the fourth quadrant. And x less than 0 and y greater than 0. That is in the second quadrant. So which option is correct? First option. Yeah, option 1 is correct answer. Any doubt in this?
Yes, sir.
Clear. Okay, thank you. I think now it is clear. So study that theory. Then anyway, in a part B, at least one question you can see from this. Hyperbolic, elliptic and parabolic. So study this. Maybe question is different, but theory is same only. You can see almost all paper, this type of problems will come. So try to study that. Yeah, we will go to the next one now. Next problem. This is the question. Question number 2. The Cauchy problem. The Cauchy problem. The Cauchy problem. The Cauchy problem. X ux. Ux means dou u by dou x plus y uy equal to 0. U of x comma y. U of x comma y is equal to x on x square plus y square equal to 1. Has this Cauchy problem has option A solution for all x belongs to R. A solution for all x belongs to R, comma y belongs to R. And option 2, A unique solution in a unique solution in a unique solution in set of ordered pair xy belongs to R square such that ordered pair xy not equal to origin 0 0. Option 3, a bounded solution in a bounded solution in set ordered pair xy belongs to R square such that ordered pair xy not equal to origin 0 0. Option 4, a unique solution in said ordered pair xy belongs to R square such that ordered pair xy not equal to 0 0, but the solution is unbounded. But the solution is unbounded. These are the options. Yeah, is it written? The Cauchy problem, x ux plus y uy is equal to 0, u of x comma y is equal to x on x square plus y square is equal to 1 has a solution for all x belongs to R comma y belongs to R. A unique solution in set ordered pair xy belongs to R square such that ordered pair xy not equal to 0 0. A bounded solution in set of all ordered pair xy belongs to R2 space such that ordered pair xy not equal to 0 0. A unique solution in set ordered pair xy belongs to R2 space and xy not equal to 0 0, but the solution is unbounded. What is the is it you written?
Yes, sir.
Yes, sir.
Yeah. Can we let us see what is a Cauchy problem? I will give you a little bit theory behind this Cauchy problem. Then we will solve this answer. Let us see this solution for that. Let, this is a theory, let f of u comma v, f is a function of u comma v, or you can written as like this also. V is a function of g of u, be the general integral, be the general means solution, be the general integral of the PDE of the form PDE P plus is equal to R, where u of x comma y comma z is equal to C1, v of x comma y comma z is equal to C2. You will understand when once we problem is solving, you can understand what is this, all the things are the solution of the equation, solutions of the equations dx by p of x comma y comma z equal to dy divided by q of x comma y comma z and dz by r of x comma y comma z. Okay, let C be the capital C be the given curve whose parametric equations are given by parametric equations are given by x is equal to x naught of s, y equal to y naught of s. S is a parameter here, and z equal to z naught of s. For s is the parameter. Okay, then we want to, I'm roughing this. Okay, we want to find the particular f such that the surface f of u comma v equal to 0 contain the initial curve C. Okay, we want this is our task. We want to find a particular f such that the surface f of u comma v equal to 0 contains the initial curve C. Okay, for that what we will do, consider the equations. That is a Cauchy problem. Consider the equations. If we solve that problem, you will understand what is this all the things. U of x comma y comma z is equal to C1. You can take this is C1, and v of x comma y comma z is equal to C2. U of x comma y comma z is equal to C1, and v of x comma y comma z is equal to C2. Okay, then substituting x is equal to x naught of s, you can substitute, and y equal to y naught of s, and z equal to z naught of s. In this equation, then we get u of x naught of s, comma y naught of s, comma z naught of s equal to C1, and similarly v of x naught of s, y naught of s, z naught of s equal to C2. The relation between them we can given by f of C1 C2 is equal to 0. That is the solution for this. Now let us come to our problem. Then we can understand. One more, if you want to this theory, you can check the Amarnath textbook. Then you will get it. Now let us see our problem. Then you will, what is this procedure, you will understand. Okay, let's see here. Given PD is, yeah, now see the correct procedure. Given PD is x into ux dou u by dou x plus y into uy equal to 0. Yes, that is our given PD. X into ux plus y into uy is equal to 0. Along with u of x comma y is equal to x, they are given on x square plus y square is equal to 1. X square plus y square is equal to 1. Now we can find the Lagrange's auxiliary equation for this. That is the Lagrange's auxiliary equation. Lagrange's auxiliary dx by p, dy by q, dz by r. That is the Lagrange's auxiliary equation. Okay. What we have here? dx by p is here just an x. Dx by x. dy by, yeah, see here, this is just a y. dy by y, the coefficient. And du, instead of z here we have u. And RHS is 0, du by 0. Solve with this. Yeah, I am taking first and last part. From this you will have du equal to 0. That means u of x comma y is equal to some c1. See how you are getting? You can take two parts. Du by 0 is equal to dx by x. Multiply by 0, multiply this. You will get du is equal to 0. Integrate it. U of x comma y is equal to c1. This is the equation number 1. Now similarly, next you take another 2. Dx by x is equal to dy by y. Okay, integrate on both sides. Log x is equal to log y plus log c2. That is a constant of the integration, log c2. From this, you can take log in this side. So x by y is equal to c2. You have x by y is equal to c2. Now you can take the parametric form. Okay, let us consider. I am going to with the parametric form. X is equal to t. Just I am taking x is equal to t. See, you have this equation. X square plus y square is equal to 1. From that, you have y equal to root of 1 minus x square. Already your x is t, so root of 1 minus t square. 1 minus t square. And moreover, they are given u of x comma y is equal to x. U of x comma y is equal to x. So this is equal to u of x comma y is equal to x is nothing but t. U of x comma y is equal to t. That means t is equal to c1. T is equal to c1. And moreover, yeah, x by y is equal to c2. So t by root of 1 minus t square is equal to c2. Okay. That means c2 is equal to c1 by root of 1 minus c1 square. C2 is equal to c1 by root of 1 minus c1 square. Okay. C2 is equal to c1 by root of 1 minus c1 square. From there, c1 square is equal to multiply c1 square is equal to c2 square into 1 minus c1 square, which implies already c1 is u square equal to u square is equal to c2 is x by y. So x by y whole square, x by y whole square into 1 minus u square. Yeah, 1 minus u square. From this you can find the u square. Yeah, u square plus, take this side. So u square into x by y the whole square is equal to x square by y square. So u square into 1 plus x square by y square is equal to x square by y square. So u square is equal to x square by x square by y square divided by 1 plus x square by y square. From this you will get this cross multiplication and everything. After this you will get x square by x square plus y square. So u of x comma y, you have square root of this. So implies x by root of x square plus y square, which is unique in x comma y not equal to 0. So I think option 2 is correct. And moreover, see u of x comma y, you have square root of x square divided by x square plus y square. The denominator is always greater than or equal to x square. So of course it's always less than or equal to 1. So u of xy is bounded also. So option 3 also correct. This is in a question from part to C. So 2 and 3 are correct. Right? Yes or no?
So can you explain the last part once again?
Okay, last part. See, yeah, here we got u of x comma y is equal to x by root of x square plus y square. That is in unique in xy not equal to 0. In R2 space not equal to 0. That is, so option 2 is correct. And moreover, u of x comma y is a square root of x square by x square plus y square. Of course, x square is always less than or equal to x square plus y square. So it's always less than or equal to 1. Denominator is more than the numerator. So it's always less than or equal to 1. So u of x comma y is also bounded also in R2 space with x comma y not equal to 0. So it is unique and bounded. So option 2 also correct. Option 3 also correct. Clear?
Yes.
Okay. Okay, can we go to the third question?
Yes,
Yeah. Yeah, thank you. Let us move to the question number 3. Let us see this question. Question number 3. Let u of x comma t equal to exponential I omega x v of t with v of 0 equal to 1 be a solution to dou u by dou t equal to dou cube u by dou x cube. Then option 1, u of x comma t equal to exponential I omega x minus omega square t. Option 2, u of x comma t equal to e raised to I omega x minus omega square t. Option 3, u of x comma t equal to e raised to I omega x plus omega square t. Option 4, u of x comma t is equal to e raised to I omega cube x minus t. This is not the questions. Done. Let u of x comma t is equal to e raised to I omega x v of t with v of 0 is equal to 1 be a solution to dou u by dou t is equal to dou cube u by dou x cube. Then u of x comma t is equal to e raised to I omega x minus omega square t. U of x comma t is equal to e raised to I omega x minus omega square t. U of x comma t is equal to e raised to I omega into x plus omega square t. U of x comma t is equal to e raised to I omega cube x minus t. Okay, let us see the solution. No need any theory behind this. The easy problem. Okay, given, see here, given that u of x comma t is equal to e raised to I omega x v of t. Solve it. Solve it along with me. With v of 0 is equal to 1. Yeah, and dE dou u by dou t equal to dou cube u by dou x cube. So find dou u by dou t. If this is the u, that is the dou u by dou t. Dou u by dou t is equal to e raised to I omega x v dash of t. V dash of t. And you can find dou u by dou x. Dou u by dou x is I omega e raised to I omega x v of t. So likewise you do, then you will get it dou cube u by dou x cube minus I omega whole cube will come. I omega whole cube e raised to I omega x v of t will come. So that is nothing but I cube is minus I omega cube e raised to I omega x v of t. Substitute in both sides. So already dou u by dou t is e raised to I omega x v dash of t equal to minus I omega cube e raised to I omega x v of t. Okay, so cancel out it. You will get v dash of t plus I omega cube v of t equal to 0. Solve this ordinary differential equation with v of 0 is equal to 1. So dv by dt plus I omega cube v of t is equal to 0. From this, dv by dt is equal to minus I omega cube v of t. So method of separable variable, dv by v is equal to minus I omega cube dt. Solve it. So log v of t equal to minus I omega cube t plus c. So v of t you will get it. If you take log in this exponential, e raised to I omega cube t plus c will come. So that is e raised to I omega cube t into e raised to c. That e raised to c I am taking as a some other constant, or you take this as a c1. So you can take that as a c. C e raised to minus I omega cubed. Your V of t become e raised to I omega cube t. That is V of t. So now you have your u of x comma t. U of x comma t is equal to this become e raised to I omega x into e raised to minus I omega cube t into e raised to minus I omega cube t. Take it e raised to I omega outside. E raised to I omega if you take outside. E raised to a into e raised to b is equal to e raised to a plus b. X minus omega 1, you take omega square t. So which is option? Which one is option? Tell me.
Option 1.
Option 1. Yeah, good. Option 1 is the correct answer. Yeah, can we go to the next problem? Okay, next
So there
problem.
is some lagging.
Hello?
So there
Hello?
was some lagging in the connection.
Hello, I'm not understanding. Hello?
So times there is some lagging in the connection.
Okay. Maybe internet. Now it is okay?
Yes, sir.
Okay, thank you. Yeah, next problem. Question number 4. The char pits equation, or you can tell char pits auxiliary equation for the char pits auxiliary equation for the PDE of the PDE ZP square plus Q square plus X plus Y equal to 0, where P is dou Z by dou X, Q dou Z by dou Y, are given by option 1 dx divided by minus 1 minus p cube dy by minus 1 minus qp square dz divided by 2p square z plus 2q square equal to dp by 2pz and dq by 2q. Option 2 dx by 2pz dy by 2q dz by 2p square z 2q square dp by minus 1 minus p cube dq by minus 1 minus q p square. Option 3, dx by z p square dy by q square dz by 0 dp by x dq by y. The fourth option, dx by 2q dy by 2pz dz by x plus y dp by p square dq by qp square. The Charpit equation for the PDE, z p square plus q square plus x plus y is equal to 0, where p is dou z by dou x, q is dou z by dou y, are given by dx divided by minus 1 minus p cube dy divided by minus 1 minus q p square dz by 2p square z plus 2q square and etc. like this. Okay, written?
Yes, sir.
Yes, sir.
Yes, sir.
Yeah, we will go to the solution part. Little bit theory I will tell you for Charpit's acceleration equation and everything. Yeah, Charpit auxiliary. Note down it. Charpit auxiliary equation for f of, if this is the function f of x comma y comma z p comma q, where p is the dou z by dou x and q is the dou z by dou y, comma an arbitrary constant a equal to 0, then the Charpit auxiliary equation is dx by fp, where fp is the dou f by dou p, dy by fq dy by fq dz by pfp plus qfq pfp plus qfq and dp or minus dp. You can tell minus of fx plus pfz, fx plus pfz and dq by minus of fy plus qfz. This is the Charpit auxiliary equation. Okay, now let us see our problem. Dx by fp, dy by fq, dz by pfp plus qfq, dp by minus fx plus pfz, dq by minus fi plus qfz. Let's see. Yeah, our given PD is f of x comma y comma z comma p comma q, an arbitrary constant a is equal to 0. This is a function that is nothing but zp square plus q square plus x plus y equal to 0. This is a function. Yeah, by Charpit equation, what we have first? Dx by fp. you will have 2pz. 2pz. Differentiate with respect to this function. This is the function f. Differentiate with respect to p. So you will get 2pz dy by fq. You will have differentiate with respect to q. So you will get 2q. Next, dz by pfp plus qfq. p, fp already we got 2pz plus qfq. It means 2q. Then dp by fx plus pfz. fx plus pfz minus of fx. fx you will get 1. Differentiate with respect to x. fx plus pfz. p into p square. Differentiate with respect to z, you will get p square. dq by fy plus qfz. fy you will get again minus of 1 plus qfz. q into p square. Yeah. So this is nothing but dx by 2pz dy by 2q dz by 2p square z 2q square dp by minus 1 minus p cube dq by minus 1 minus qp square. Correct? Which option is correct? Tell me which option is correct?
Right?
First option.
Yeah, first option. dx by 2pz, dy by 2q, dz by 2p square z, 2q square, dp by minus 1 by p cube. Yeah, second option, right?
Yes, sir.
Second
Yes, sir.
Yeah, thank you. Second option is correct. Okay. Now we will move to the fifth problem. Fifth problem. So remember that Charpit auxiliary equation. Then you can solve it. Fifth question. Question number 5. Let u of x comma t be the solution of the initial value problem. Be the solution of the initial value problem. Initial value problem. Initial and boundary value problem. Dou square u by dou t square equal to dou square u by dou x square 0 less than x less than infinity, comma t greater than 0, along with u of x comma 0 equal to cos of pi x by 2, 0 less than or equal to x less than infinity, dou u by dou t of x comma 0 equal to 0, 0 less than or equal to x less than infinity, dou u by dou x of zero comma t equal to 0, where t greater than or equal to 0. Then Option 1, the value of u of 2 comma 2 is equal to -1. Option 2, the value of u of 2 comma 2 is equal to +1. Option 3, the value of u of 1 by 2 comma 1 by 2 is equal to 1 by root 2. And similarly, the value of u of 1 by 2 is equal to 1 by 2. Okay. Not the problem?
Yes, sir.
Okay. Then this is a wave equation. First understand this is a wave equation. For solving the wave equation, we have a D'Alembert's formula. It is an initial value problem. Then it is you can go with the D'Alembert's formula. I will give you the theory of that. Then very easy to handle. The solution of one-dimensional wave equation with initial value problem UTT mean dou square u by dot t square minus c square uxs. That means dou square u by dou x square is equal to 0 with minus infinity less than x less than infinity and t greater than or equal to 0, where u of x comma 0, initial condition they are given, u of x comma 0 is equal to eta of x, some function of x, and ut of x comma 0 is equal to some v of x. By D'Alembert's formula is solution of this. D'Alembert's formula is this is the D'Alembert's formula. U of x comma t equal to 1 by 2 by 2c eta of x plus ct eta of x minus ct plus 1 by 2c. I have a confusion here. I think this is 1 by 2 only. Eta of x plus t plus eta of x minus ct 1 by 2c integral of x minus ct to x plus ct v of xi dz. V of xi dz. Even not this one. I will check. Okay. 1 by 2. 1 by 2 eta of x plus ct, eta of x minus ct plus 1 by 2c integral x minus ct, x plus ct, v of xi dz. Okay, can we now, we will go to the solution of this particular problem. Of course, the given problem is a wave equation. Okay, here they are given like that. UTT equal to UXX. That means C equal to 1. The constant is 1 here. And U of x comma 0 is equal to cos of pi x by 2. And ut of x comma 0 is equal to v of x, that equal to 0. And this is eta of x. So u of x comma t is equal to 1 by 2 eta of x plus ct. That means cos of eta of x is cos pi x by 2. So cos of pi into c is 1 here. So x plus ct. That means x plus t will come. Pi of x plus t by 2 plus cos of pi x minus ct. That means x minus t will come by 2. And moreover, integrand is 0 here. So completely that is become 0. So now you know the formula of cos A plus cos B. Cos A plus BC, fundamental formula. Cos A plus cos B is equal to 2 cos A plus B by 2. Cos A plus B by 2 into cos A minus B by 2. Use this basic formula and solve it u of x comma t. So u of x comma t become 1 by 2 cos of pi x plus pi x by 2 plus pi t by 2 plus pi x by 2 minus pi t by 2. Pi t by 2 cancel. Pi x by 2 plus pi x by 2. Pi x will come. All divided by 2. So 2, this 2 cos again pi x by 2 will come. Cos pi x by 2. And similarly, cos A minus B by 2. So pi x by 2 minus pi x by 2, that is cancelled. Pi t by 2 minus pi t by 2. 2 pi t by 2. So 2 cancel. Again by 2. So cos of pi t by 2 will come. Apply. This is the solution. 2 you can cancel. So you have the solution like this. Cos of pi x by 2 into cos of pi t by 2. Find that points now. They are given u of 2. 2 means cos pi. Cos pi is minus 1. Again, cos pi is minus 1 into minus 1 is a plus 1. U of 2 is plus 1. Next, u of 1 by 2 equal cos of pi by 2 into 1 by 2. 2 into 1 by root 2 is a 1 by 2. So what are the options are correct?
2 and 4.
2 and 4, right? 2 and 4, right? Correct?
Yes, sir.
Okay. So next problem you can do. Yeah. Some 25 minutes only I will take. 12 o'clock I will stop it. Don't worry. Within that we'll do some more problem. Sixth question. The second order PDE. This is easy. Already theory I given. Solve it. Tell me the answer. The second order PDE is all are CSIR. Okay. Second order PDE. UYY minus Y UXX x cube U equal to 0 is option 1 elliptic for all x belongs to R, comma y belongs to R. Option 2 parabolic for all x belongs to R, y less than 0. Option 4 hyperbolic for all x belongs to R, y less than 0. Solve it and tell me the answer fast. I'm not going to solve this. Solve it. Yeah, here R is equal to minus y, s is equal to again 0 only, t is equal to again 1. Find s square minus 4rt. S square minus 4rt. 0 minus 4 into minus y into 1. That means minus plus 4y will come. Okay. Yeah. Elliptic. Elliptic means less than 0. Whenever y less than should be less than 0. 4 is always greater than 0. So if it is less than 0 implies y should be less than 0. For all x can be any number. Yeah. I think option 3 is correct answer. Elliptic. No, this is wrong. Parabolic. No, y belongs to, no, it is not parabolic. Hyperbolic. Now, whenever y is less than 0, it is elliptic only. So option 3 is correct. Correct? Clear, right?
Yes, sir.
Sir.
Okay. Next problem. 7th problem. Seventh question. The PDE dou u by dou t equal to dou square u by dou x square plus u can be transformed to to dou v by dou t equal to dou square v by dou x square. For option 1, v equal to e raised to minus tu. Option 2, v equal to e raised to tu. Option 3, v equal to tu. Option 4, v equal to minus tu. Okay, so just I am going with the option itself. Yeah, our given PDE is dou u by dou t. Dou square u by dou x square plus u. So v is equal to e raised to minus. This is from part B. Okay, only one option is correct. No issue. So you have take this side. So e raised to t into v. Transform d. So dou v by dou t become dou u by dou t. I think dou u by dou t. So dou u by dou t is equal to e raised to t into v. So v is also a function of v of x comma t. First into e raised to t into, or first v into derivative of e raised to t is v only, plus e raised to t into second into derivative of first, so vt, or dou v by dou t is will come. V e raised to t plus e raised to t into dou v by dou t. Understand, v is also function of x comma t. Next, dou square u by dou x square. This e raised to t, just a vxx. Substitute all in this given equation. Dou u by dou t is nothing but v e raised to t plus e raised to t vxx. So e raised to t into dou v by dou t equal to e raised to t dou square v by dou x square plus u. U is nothing but e raised to t into v. Cancel these two. So e raised to t we cancel. You will have dou v by dou t equal to dou square v by dou x square. Of course, this is it can be transformed to this with this v. Only one option is correct because this is a question from part B. So option 1 is correct. You can check the remaining. Of course, 2 is never 0 and this is a linear. There is no chance for that. Clear? Okay.
Yes.
Okay. We will move to the next problem.
Yes, sir.
Yeah. Thank you. I think 8th question. Let u of x comma t satisfy for x belongs to R and t greater than 0, dou square u by dot t square plus dou u by dot t 2 into dou square u by dou x square equal to 0, a solution of the form u equal to e raised to ix into v of t with v of 0 is equal to 0 and v dash of 0 is equal to 1. Option 1 is necessarily bounded. Necessarily bounded. Option 2 satisfy modulus of u of x comma t less than e raised to t. Option 3 is necessarily unbounded. Necessarily unbounded is oscillatory in x. Option 4 is oscillatory in x. That u of x comma t satisfy for x belongs to R, t greater than 0, dou square u by dot t square plus dou u by dot t plus 2 into dou square u by dou x square is equal to 0. A solution of the form u equal to e raised to ix v of t with the v of 0 is equal to 0 and v dash of 0 is equal to 1. It's necessarily bounded. Satisfy modulus of u of x comma t is less than e raised to t is necessarily unbounded, is oscillatory in x. Yeah, let us see the solution. Let us see the solution. Yeah, given that, you see, here it is given that dou square u by dot t square plus dou u by dot t plus 2 into equal to 0. This is given. So, see, and moreover, solution of the form e raised to ix into v of t. And v of 0 is equal to 0. That is there. V dash of 0 is equal to 1 also. Substituting this. So, e raised to ix dou square u by dot t square v double dash of t will come. Plus dou u by dot e raised to ix v dash of t plus 2 into v of t. I will come outside, so I into I is minus I square. So so I square is negative 1 minus e raised to ix will come equal to 0. Ix e raised to ix എല്ലാവരും cancel ചെയ്യാൻ പറ്റും, or e raised to ix take common v double dash of t plus v dash of t minus 2v equal to 0. So e raised to ix is never be 0. So only v double dash of t plus v dash of t minus 2v equal to 0. That is only possibility. This is a second order ordinary differential equation. So Okay, sorry, current is gone. Now I am audible.
Yeah.
Yes, sir.
Yeah. So gone, no issue. M is equal
Sir, not
to plus 1. Audible?
no, sir, not that clear.
Your voice is breaking, Rafeek.
Now is gone. I'm-
Uh, Rafeek, you can switch off your video if there is not that much network, then- and try to speak.
Yeah, now it is visible, my screen.
Yes. Yes, it's okay now.
Okay, thank you. So m plus 2 into m minus 1, of course, m plus 2 into m minus 1, m plus 2 into m minus 1 is equal to 0. From this you will get m is equal to minus 2 and m is equal to 1. These are the two characteristic roots. So you will have the solution of this ODE like this. V of t is equal to C1 e raised to t plus C2 e raised to minus 2t. Yeah, now use the conditions. V of 0 is equal to 0. From this, C1 plus C2 is equal to 0. And you can differentiate our solution. V dash of t is equal to C1 e raised to t minus C2 e raised to minus 2 into C2 e raised to minus ut will come. 2C2 e raised to minus ut. Use the V dash of 0 is equal to 1. So V dash of 0 is equal to 1. From this, 1 is equal to C1 e raised to 0 is anyway is 1 only, minus 2C2. Solve these two equations. First equation, C1 plus C2 is equal to 0. Another is C1 minus 2C2 is equal to 1. So this. Subtract it. C1, 0s, 3C2. 3C2 is equal to subtraction, right? So minus 1, C2 is equal to minus 1 by 3. So C1 is equal to plus 1 by 3. So your solution now like this only. Your solution now like this. V of t is equal to 1 by 3 e raised to t minus 1 by 3 e raised to minus 2t. That is V of t. So U of x comma t is equal to e raised to ix into V of t. So e raised to ix into 1 by 3 e raised to t minus 1 by 3 e raised to minus 2. That is U of x comma t. Let us see the modulus of this. Now we can check the each and every options. So mod e of x into 1 by 3 e raised to t minus 1 by 3 e raised to minus 2t. Of course, e raised to ix is nothing but cos x plus I sin x. Modulus of that is always is equal to 1 only. So e raised to modulus of ix. cos square x plus sin square x will come. That is 1 only. So mod, this can be written as, because of the properties of modulus function, e raised to ix into 1 by 3 e raised to t minus 1 by 3 e raised to minus 2t. From this, and say is equal to 1 only, means this is equal to e raised to t by 3 minus 1 by 3 e raised to 2t cross multiplication 3 e raised to t e raised to f e raised to 3t minus 9 e raised to 3 the common minus 1 by 9 e raised to t. Of course, so 1 by 3 will come. Yeah, e raised to 3t by e raised to 2t is take as a common. E raised to 3t divided by e raised to 2t is e raised to t minus some 1 by e raised to 2t. Of course, it's always because you are subtracting. Second, you are subtracting, and moreover, it is a 1 by 3 into e raised to t. So, of course, it's less than e raised to t only. So, u of x comma t. This option is correct. U of x comma t is less than e raised to t. That is 1. So, of course, it's an unbounded. If t tends to infinity, this also tending to infinity only. Implies u of x comma t is unbounded. Option 2 and 3 is correct. And moreover, it's an oscillatory solution only because e raised to ix is there. Cos x plus sin x is there. So that is oscillatory nature. It is in oscillatory nature. So option, what are the options? Is an oscillatory next. Is necessarily unbounded and is satisfied. U of x comma t is less than x.
Yeah, the is.
Good afternoon, sir. Sir, I am Diya. I am Diya Shah. I am in M.Sc second year, and sir, today's class is really nice, and it is great for CSIR NET preparation. Sir, I have one doubt in question 6. Sir, you have done by checking checking the options. Is there any
Right.
other way to that?
Okay, I think question 6 means can you read?
Sir, it is no, sir. Sorry, question 7. Del u do u do t is equal to do u do square u do x square plus u. It can be
Yeah,
transformed.
correct. The thing is nothing but the better option is go with the option only that. Because one thing is sure, we see option 3 and 4 are linear. You can do very easily, right?
Yes, sir.
These, yeah, and the remaining are if one is correct, then 2 is not correct. Like that functions only. So better to go with the option only. Maybe it is applicable also. Some other way also applicable. It is there.
Hello,
Yes.
sir.
Yeah,
Good
Shikha.
afternoon. I'm Shikha from VIT Mishra, Jharkhand. I'm a second year M.Sc student. So in the last question, after modulus, what you have explained,
Okay.
I was unable to understand.
Yes.
Can you repeat once, please?
Yeah, I will. Yeah, up to here it is clear. Modulus of u of x comma t is less than e raised to t, right? Up to here it is clear.
Yes, sir.
Yeah. One thing is sure. This is an unbounded function because once t tending to infinity, the function also may tending to infinity. So you are unable to get a bound for this. So it is an unbounded. And moreover, so what are the options here? One is this only. Satisfy norm of modulus of u of x comma t is less than e raised to t. So that is satisfying. And another one is necessarily unbounded. So 2 and 3 are correct. And moreover, our function is like this only. u of x comma t is equal to e raised to ix into 1 by 3 e raised to t minus 1 by 3 e raised to minus 2t. E raised to ix you can written as like this, cos e raised to I theta cos theta plus I sin theta. 1 by 3 e raised to t minus 1 by 3 e raised to minus 2t. So it has some oscillatory nature because these are the oscillatory functions, right? So it is as an oscillatory nature also. So a last option also correct.
Rafeek, are you hearing something? I am
No,
not
no, no,
hearing.
sir, no, sir. I am unable to hear.
Dharmendra, your voice is not coming. I am seeing you. You are speaking something, but yeah, maybe or try again or by rejoining. I think you can just exit and again rejoin. That will be better. I think. Okay, others, please do come forward. Yeah, Dharmendra is asking for some references to prepare PD.
Wait. Mm. Yeah, my concern is you better to go with an elementary course in partial differential equation by T. Amarnath. He's a professor in HCU, Hyderabad Central University. Better to go with that because it is easy to understanding also. An elementary course in partial differential equations by T. Amarnath. Okay.
Okay.
Yeah.
Others?
Hello, sir.
Yeah.
I'm Gayatri. I have studied in Miranda House College, Delhi. It was a nice class, and you have taken the class very slowly, and you have written everything, so it was easy to understand and note down the points.
Thank you,
sir.
Thank you.
Thank you, Gayatri. Others?
Sir, myself, Virupaksha. The session was very good, and sir will explain very neatly, and everyone will understand easily. I hope that. And I hope upcoming exams, these are the questions will be easy for us. Thank you, sir. Thank you, Rafeek, sir.
Thank you.
Yeah, thank you, Virupaksha, and all the best for your exams. Others?
Hello, sir.
Yeah.
I am Biswas. I am a M.Sc second year student from Iritty Trichy. Sir, today's session was very nice, and you introduced theorems as well as problems, and that will help us to clear up to our upcoming exams. So thank you so much, sir, for your time and for give us time. Thank you, sir.
Thank you.
Thank you, Titi. Others? If any of you would like to express any comments, you can do it now.
Sir, am I audible?
Yes.
So I am Anamika E from Zamarin's Guraipan College. I'm a BSc third year student, and I know it's difficult to, as you know, that it is difficult to understand this topic in BSc level, but it's you take the session very slowly, and I think everyone can understand these parts. I mean, MSc students, I try to attend the class well. And thank you, sir, for sharing this much time for sparing this much time for us. And can you explain your experiences in your MSc classes and your studies?
Yeah, it's really nice. Yeah, like this only, it is a difficulty to understand every concept, but go with the prescribed textbook and try to understand it. That's it. That is the only one way. And do in future you do the research and everything.
Yeah, in the BSc level, watching these type of classes will be certainly useful to at
Yeah.
least to know that there are something more to study in PG.
Yes, sir.
And
Definitely.
moreover, she is interesting. That's what for this BSc itself, she is attending the class. That also very
Yeah,
nice.
yeah, yeah. Yes. Thank you, Anamika. Any other? I think,
Sir, I have one more question.
yeah,
Yeah.
Shiga.
So, what is the weightage of wave equation, Laplace equation, and heat equation among the other topics in PD for CSIR NET exam?
Yeah, I think more questions we can see from this parabolic nature type. At least one question it will come all the time. Hyperbolic type. You to check the hyperbolic type or parabolic type or elliptic type. That one. And moreover, sometimes it is comes a wave equation. Sometimes it comes heat equation. And moreover, now this NTA is conducting. They need to know more concept ways. Not only the previous year, what is the question is going on, they are not following that one. So better to go with all the textbook only. Like for a partial differential equation, you go with this Amarnath textbooks, linear algebra, something else, something else. So basically, you go with all the things, then you practice the questions, and don't much go with only with the questions. You try to understand the concept also. Then only the nowadays you can crack the competitive exam. The previous 2 to 3 years before, I think whatever the same model only they are following, but nowadays they are checking your concept also. So try to learn from textbook only.
Okay,
This is
sir.
my case. And we weightage is telling is so difficult. That is depends upon that who's conducting and who's preparing. Yeah,
Yeah,
that's it.
certainly the questions will depend upon the mindset of question paper setters.
Yes, definitely.
Their interests will be get reflected in that.
Yeah, and moreover, which institute is conducting for their interest also will be there in that.
So, Shiga, the thing that you can do is that you have to get well prepared to face any type of questions. That is the better option, I think.
Yes, sir.
All the best, Shiga.
Thank you, sir.
Yeah.
Thank you, sir.
Am I audible?
Yes. Yeah, yes. Yes, Dharmendra.
I am Dharmendra Singh from BARC Visakhapatnam, now doing job in library, but I also doing mathematics preparation for JAM and etc. etc. I want to ask how can I do self-study if I faces some problem, how can solve myself?
Yeah, in my concern, only go with the textbooks. A textbook from neatly they will explain it. So
Can you
ask,
told other topics textbook also, sir?
yeah, which one? If it is abstract algebra, that contemporary abstract algebra is there, na? Like that,
Then,
for all textbooks are available. Linear algebra also you can get it. Ask to someone also, like which is the favorite for them. Someone will interest more about linear algebra, so go with, to ask to them which is the your favorite and which one is we can understand. That a lot of textbooks are there, but the thing is nothing but
yes.
you can understand or not. In that pattern, which one is written, go with that only.
Yes, sir. Okay.
Dharmendra, you can have Sham series in almost all the areas. So
Yeah.
that contains many solved problems. So that
Yes,
will
sir.
certainly help you in your preparations. And
Yes, sir.
also, there are many lectures available in YouTube, like NPTEL, and lectures by various universities are available in nowadays in YouTube. So you can search in YouTube and identify the lectures in your concerned topic and watch it. That will be definitely useful.
Yes, sir. Yes, sir.
Nowadays, it is not a big problem. If you have a strong wish and mind, then definitely there are many ways to study. So
Yes, sir.
I think situation is almost very open now. So there is nothing problem as compared to the previous days. Okay.
Yes, sir. Yes, sir. Thank you, sir.
And ordinary
you, bro, sir.
differential equation, you can go with the GF Simmons. GF Simmons.
Yeah. Yeah.
Okay, sir. Okay.
So
Thank you,
thank you,
sir.
Dharmendra. Yeah,
Yes,
and
sir,
all the
yes.
best. And appreciating your interest. Still, you are doing job as a librarian.
Yes, sir. Yes, sir.
Okay.
Thank you, sir.
So yeah, any others would like to speak? Then please do it now. Otherwise, we will wind up. Gopika, Malavika, there are someone I'm seeing. So if any of you are interested to speak now, make it now. So thank you, Rafeek, for this session on partial differential equation.
Thank you, sir. Thank you so much for you to give this type of opportunity. Thank you so much.
So I hope that I hope today's session will be helped many people in their preparations for in their last minute preparation for CSIR NET. So Rafeek, all the very best for your academic career. Once again, my sincere thanks for being with Math Aspirants groups.
Thank you, sir. And for me, I am also thanking to you. You given for this time also opportunity to us. That is the great. Thank you, sir.
Okay. Yeah. Okay. So thanks to everyone, and wish all of you all the success in the coming exams. Okay, let us wind up here. Thank you.